Imagine standing in a silent cave, your torch flickering against limestone walls. Your fingertips trace over ancient handprints pressed into clay 40,000 years ago. The palm is broad, the fingers short. This is not your hand. This is not even your species. These are the final traces of those who came before us. Neanderthals, our evolutionary cousins who dominated Europe and Western Asia for over 300,000 years. Beings who survived ice ages, crafted tools, buried their dead, and then disappeared. Picture a world where two human species shared the planet. For thousands of years, Homo neanderthalensis and Homo sapiens existed side by side. They encountered each other, perhaps spoke, perhaps fought, perhaps loved. Then suddenly, one vanished forever. The conventional explanation feels deceptively simple. Modern humans arrived, outcompete Neanderthals, and nature took its course. But in science, simplicity can be misleading. The more closely researchers examine the evidence, the more this explanation begins to unravel at the edges. Why did a species that survived multiple ice ages, that had larger brains than us, that had successfully adapted to harsh conditions for hundreds of millennia, abruptly disappear within a few thousand years of our arrival? The timeline itself presents a puzzle. In some regions, Neanderthals persisted alongside modern humans for thousands of years. If direct competition were the sole factor, why such a gradual decline? And why do many Neanderthal sites show no evidence of modern humans nearby during their final days? The mystery deepens when we consider their capabilities. Neanderthals controlled fire, crafted complex tools, created art, adorned themselves with pigments and jewelry, and possibly developed language. These were not simplistic beings easily outmaneuvered by newcomers. More perplexing still is what we carry within our own DNA. Most people of Eurasian descent possess between 1 and 4% Neanderthal genetic material. We didn't simply replace them, we absorbed them. Yet the nature of those interactions remains largely unknown. Climate change offers another possibility. The period of Neanderthal extinction coincided with severe environmental fluctuations. But why would these climate shifts affect Neanderthals so catastrophically while sparing Homo sapiens who had less evolutionary history in those regions? Disease presents yet another theory. Perhaps pathogens carried by modern humans devastated Neanderthal populations with no immunity. But the archaeological record has yet to yield conclusive evidence of such a pandemic. The truth remains elusive, hidden in fragments of bone and stone. You are about to enter a world of scientific uncertainty, where evidence is limited and theories abound. The disappearance of our closest evolutionary relatives represents one of the most profound mysteries in human origins, a case where the more we learn, the more questions emerge. Tonight, we will journey back to the twilight days of the Neanderthals. We will examine the geological, archaeological, and genetic evidence. We will explore competing theories and the latest scientific discoveries that continue to reshape our understanding of this enigma. This is more than an academic puzzle. It's a story about survival, adaptation, and possibly the very nature of what makes us human. If we truly understand the Neanderthal disappearance, we might better comprehend our own precarious existence on this planet. Tonight, we explore what almost nobody fully understands: how a highly successful human species that dominated Eurasia for hundreds of thousands of years could vanish so completely, leaving only whispers in our DNA and handprints on ancient cave walls. The Neanderthals were not simply replaced, they were silenced. And the exact mechanisms of their extinction remain one of the most profound mysteries in the story of human evolution. Tonight, we step into the shadows between what we know and what we can only guess. So settle in as we journey back through time to a world where multiple forms of humanity shared the earth. A world that was about to change forever. A world where one type of human would inherit everything, while the other would leave nothing but bones and questions. Tonight, we will explore what happened during that pivotal moment in prehistory when our paths crossed and then diverged forever, and why, despite all our scientific advances, the full story of the Neanderthal disappearance remains stubbornly beyond our grasp. Chapter 2: The Shadow of Our Past. The mystery of the Neanderthal disappearance isn't just an academic curiosity. It's a profound question about human uniqueness and our place in the natural world. For centuries, we've defined ourselves as exceptional beings, standing apart from and above the rest of nature. But Neanderthals challenged this narrative. They possessed larger brains than modern humans. They survived in harsh environments that would challenge even today's technology. They created art, crafted complex tools, and potentially developed their own forms of language and culture. And yet, they vanished while we flourished. Understanding why matters because it forces us to confront uncomfortable questions about our own species. Are we truly exceptional, or simply the last survivors of what was once a diverse human family? The stakes of this mystery extend beyond anthropology into the realm of our own identity. If Neanderthals disappeared through random climate events rather than competitive inferiority, what does that say about human destiny? Were we simply lucky rather than special? Or perhaps more unsettling, if we played a direct role in their extinction through violence, disease transmission, or resource competition, what does that reveal about our fundamental nature? Are we inherently destructive to those different from ourselves? The implications ripple outward. If we cannot fully explain the disappearance of a highly adapted hominin species that existed alongside us, how confident can we be about our own species' resilience? What lessons might their extinction hold for our own future? Consider the profound implications of what we've learned from Neanderthal DNA. We now know interbreeding occurred, meaning they were not a separate species in the strictest biological sense. They were different from us, yet similar enough that we could produce fertile offspring. This genetic evidence forces us to reconsider fundamental categories of human and non-human. The boundaries we once thought clear have blurred. Neanderthals were not simply replaced. Parts of them survive in most non-African populations today. Yet despite carrying their genes, we understand remarkably little about them as a people. We don't know if they had complex language, though their hyoid bones suggest they could speak. We don't know their spiritual beliefs, though they buried their dead. We don't know how they perceived us when modern humans first appeared in their territories. Were we seen as enemies? Trading partners? Potential mates? The archaeological record offers tantalizing clues, but no definitive answers to these profound questions. The mystery matters because it represents a road not taken in human evolution. Neanderthals were a viable, successful variant of humanity that existed for far longer than our species has been around. Their extinction represents the loss of an entire way of being human. Had they survived alongside us, our conception of humanity itself would be fundamentally different. We would not be the only humans on Earth. Our religions, philosophies, and scientific frameworks would all need to accommodate multiple forms of personhood. This alternative history, a world where multiple human species coexisted into the present, feels almost like science fiction. But it nearly happened. For thousands of years, it was reality. And then, for reasons we still debate, it ended. What makes this mystery particularly compelling is how recent it actually is. The last Neanderthals likely disappeared around 40,000 years ago, a mere moment in evolutionary time. Some isolated populations may have persisted even later, perhaps until 28,000 years ago. For context, the first cities emerged only 10,000 years ago. Writing developed roughly 5,000 years ago. The Neanderthal extinction occurred just 10 times further back than the building of the pyramids, recent enough that we can almost touch it. And yet, despite this relative proximity in time, despite advanced DNA analysis, despite sophisticated archaeological techniques, we still cannot definitively explain what happened. The clues are fragmentary, the evidence incomplete, the theories numerous. This persistent uncertainty should humble us. If we cannot fully explain the disappearance of our closest relatives, beings whose bones we can hold in our hands, how confident should we be about other aspects of our deep history or our long-term future? The mystery also matters because it represents one of the most significant case studies in extinction and survival. What factors ultimately determine which lineages persist and which vanish? The answer has implications not just for our past, but for our future. As we face unprecedented global challenges, climate change, biodiversity loss, emerging diseases, understanding why one highly successful human species disappeared while another flourished might offer crucial insights into our own vulnerability and resilience. Furthermore, the Neanderthal question forces us to confront the provisional nature of scientific knowledge. Each decade brings new discoveries that reshape our understanding. Theories that seemed certain crumble under new evidence. The story continues to evolve. In the 1960s, Neanderthals were portrayed as stooped, brutish cave dwellers, barely human. Today, we recognize them as sophisticated beings who created art, used medicinal plants, and possibly had speech. Tomorrow's discoveries will likely transform our understanding yet again. This evolving narrative reminds us that science is not a collection of facts, but a process of progressive refinement. The gaps in our understanding of Neanderthal extinction aren't failures of science, but opportunities, spaces where new discoveries await. The mystery invites us to hold multiple possibilities simultaneously, to embrace uncertainty as a proper scientific stance. Perhaps there was no single cause for their disappearance, but a complex interplay of factors: climate shifts, competition, interbreeding, and sheer chance. Tonight, as we explore this ancient enigma, we're not simply discussing the fate of a long-vanished human species. We're probing the very nature of humanity itself, the fragility of existence, and the thin line between survival and extinction that all species walk. By the end of our journey, you may not have definitive answers. The evidence doesn't yet permit them. But you will understand why this question continues to captivate scientists and why its resolution matters for how we understand ourselves and our place in the natural world. Chapter 3: The First Humans of Europe. Long before modern humans set foot in Europe, another people had already mastered the continent. For over 300,000 years, Neanderthals reigned as Europe's dominant human species. Their story begins not with their disappearance, but with their remarkable emergence and adaptation. The evolutionary journey of Neanderthals likely began around 700,000 years ago, when an ancestral population, possibly Homo heidelbergensis, began to adapt to the unique challenges of Ice Age Europe. Generation by generation, they evolved distinctive traits suited to this environment. Their bodies grew robust and powerful, with barrel chests and short, sturdy limbs that conserved heat in frigid conditions. Their facial structures changed too: prominent brow ridges, large noses for warming cold air, and powerful jaws adapted for a high-protein diet. Most remarkably, their brains grew larger than those of modern humans, averaging 1,600 cubic centimeters compared to our 1,400. While brain size isn't everything, this challenges simplistic narratives about Neanderthal cognitive inferiority. By 250,000 years ago, fully recognizable Neanderthals had emerged. Their range extended from the Atlantic shores of what is now Portugal and Spain to the Altai Mountains of Central Asia, and from the Mediterranean to the North Sea. These were not wandering nomads barely surviving. They were masters of their environment, developing sophisticated strategies for hunting large, dangerous animals like woolly rhinoceros, mammoth, and cave bears, prey that would terrify most modern humans. Evidence from sites like Abric Romani in Spain shows they organized their living spaces with designated areas for different activities, early forms of home design. They controlled fire not just for warmth, but for cooking, hardening wooden spears, and possibly even medicinal purposes. Their technological innovation is evident in the Mysterian tool tradition, a diverse toolkit including scrapers, points, and specialized cutting implements. These weren't crude rocks, but carefully crafted instruments requiring planning, precision, and knowledge passed through generations. Contrary to early stereotypes, Neanderthals were not solitary brutes. Archaeological evidence consistently shows they lived in small, close-knit bands. They cared for injured and elderly members who survived years with debilitating injuries. Impossible without community support. At Shanidar Cave in Iraq, a Neanderthal man was discovered who had survived multiple serious injuries, including a crushed skull and withered arm. He lived for years after these injuries, indicating his group provided substantial care rather than abandoning him. Perhaps most moving is their treatment of the dead. Neanderthals were among the first humans to deliberately bury their fallen. At La Chapelle aux Saints in France, an elderly man was placed in a prepared pit, potentially with grave offerings, suggesting ritual and symbolic thought. For hundreds of thousands of years, Neanderthals weren't just surviving in Europe, they were thriving. They developed cultural traditions that persisted with remarkable stability across vast time periods and geographic spaces. They had found their niche and mastered it. This was the world before us, a Europe and Western Asia populated by a different kind of human. a parallel humanity with their own ways of understanding and moving through the world. A people who had solved the challenges of Ice Age survival through biological and cultural adaptation. Then, something changed. Around 45,000 years ago, a new human species began to appear in Neanderthal territories. Homo sapiens, anatomically modern humans, had evolved in Africa and were now expanding outward across the globe. These newcomers were different, taller, more gracile, with higher foreheads and smaller faces. Their technology, while built on similar principles, showed innovations including compound tools that combined multiple materials, standardized bone implements, and eventually projectile weapons. The meeting of these two human species represents one of history's most profound encounters. Two intelligent, tool-using, culturally complex human forms, separated by hundreds of thousands of years of separate evolution, now sharing the same landscapes. For a time, they coexisted. In some regions like the Levant, the archaeological record suggests alternating periods of occupation by Neanderthals and modern humans over thousands of years. The boundaries between their territories shifted with climate fluctuations. This wasn't a simple story of rapid replacement. In some areas, Neanderthal populations persisted alongside modern humans for millennia. The so-called Châtelperronian industry of France and northern Spain shows Neanderthals adopting elements of modern human technology. Then came a period of intense climate instability between 43,000 and 38,000 years ago. Ice cores reveal rapid shifts between warming and cooling events. For populations already under pressure, these environmental changes may have pushed many beyond their adaptive capacity. The last definitively dated Neanderthal remains come from Gibraltar, around 40,000 years ago, though some controversial evidence suggests isolated populations may have persisted until 28,000 years ago. After more than 300,000 years of success, they vanished from Earth. But not completely. The most startling revelation of modern genetics is that Neanderthals live on within us. Between 1 to 4% of the DNA in non-African populations comes from Neanderthal ancestors, evidence of interbreeding between the two human species. This genetic legacy includes immune system components, skin and hair characteristics, and even genes influencing how certain populations metabolize fat. Parts of Neanderthals survive, incorporated into our own genetic makeup through ancient encounters. The story of Neanderthals is not simply prehistoric background to human history, it is human history. They were not evolutionary dead ends, but a successful human adaptation that persisted 20 times longer than recorded civilization has existed. Their disappearance represents the loss of a fundamentally different way of being human. Understanding how and why they vanished isn't just about solving an ancient mystery. It's about understanding the fragile thread of circumstances that allowed our own species to become the last human standing. Chapter 4: Clues in Stone and Bone. The investigation into the Neanderthal disappearance begins with what they left behind: tools, hearths, butchered animal bones, and occasionally, their own skeletal remains. These fragments form a puzzle that has taken over a century to piece together and remains incomplete. The first recognized Neanderthal fossil was discovered in 1856 in Germany's Neanderthal Valley. Scientists initially mistook the robust skeleton for that of a deformed modern human or ancient Cossack soldier. The concept that it represented an extinct human species was revolutionary. As more specimens emerged across Europe, a pattern became clear. These weren't isolated anomalies, but representatives of a distinct population that had once dominated the continent. The quest to understand their fate had begun. The primary evidence comes from archaeological sites where stratigraphic layers tell stories of occupation and abandonment. In many locations, Neanderthal artifacts give way to modern human technologies in higher, more recent layers, a visual record of replacement. At Gorham's Cave in Gibraltar, Neanderthal tools have been found in layers dated to about 40,000 years ago, currently representing their last known presence on Earth. Above these layers lie the remains of modern human occupation, a literal stratification of human history. But the evidence isn't always straightforward. In some sites, layers containing Neanderthal artifacts show signs of increasingly sparse occupation before disappearing entirely, with no immediate modern human presence above. This suggests some populations vanished before direct contact. In other locations, Transitional layers contain technology that seems to blend Neanderthal and modern human approaches. The Châtelperronian industry of France and northern Spain shows Neanderthal toolmaking incorporating elements previously associated only with modern humans. This cultural hybridization suggests a period of interaction and influence rather than immediate replacement. For thousands of years in some regions, the two human species appear to have observed and perhaps learned from each other. The dating of these transitions proves crucial. Using radiocarbon dating, thermoluminescence, and other techniques, scientists have established that Neanderthals disappeared at different times in different regions, a rolling extinction rather than a single catastrophic event. In parts of Eastern Europe and Western Asia, Neanderthal populations appear to have vanished around 50,000 years ago. In Western Europe, they persisted until about 40,000 years ago. This gradual disappearance complicates simplistic replacement narratives. The geographic pattern reveals another clue. Neanderthals seem to have made their final stand in the most western and southern parts of their range, the Iberian Peninsula, particularly modern-day Portugal and southern Spain. These regions may have served as refugia, isolated areas where small populations could persist after disappearing elsewhere. The pattern suggests a gradual contraction of territory rather than sudden, uniform extinction. Climate evidence adds another dimension. Ice cores from Greenland show the period between 43,000 and 38,000 years ago experienced dramatic climate instability, a phenomenon known as Heinrich Event 4, causing rapid shifts between warming and cooling periods. For populations already under pressure from competition and possibly disease, these environmental fluctuations may have been catastrophic. Neanderthals had survived previous climate changes, but perhaps not while simultaneously facing other stresses. Notably, these climate shifts coincided with the arrival of modern humans in Europe. Our species may have possessed cultural adaptations, like more efficient hunting technologies or better clothing, that allowed greater resilience during environmental instability. The most revolutionary evidence comes from genetics. In 2010, scientists published the first draft sequence of the Neanderthal genome, extracted from bones over 40,000 years old. This genetic time capsule transformed our understanding of their fate. Comparison between Neanderthal and modern human genomes revealed something unexpected: interbreeding. Most people of Eurasian descent carry between 1 to 4% Neanderthal DNA, conclusive evidence that the two human types produced fertile offspring. This genetic evidence forces us to reconceptualize the Neanderthal disappearance. They weren't simply replaced, they were partially absorbed through interbreeding. Their lineage continues within many of us, a ghost population living in our genes. Furthermore, genetic analysis of the Neanderthal genome reveals a population that was already declining before modern human contact. Their genetic diversity was low, suggesting small, isolated groups vulnerable to inbreeding and reduced adaptive capacity. A 2019 study in PLOS One suggested that even modest levels of interbreeding, as low as 5% every generation, could have led to Neanderthal genomic extinction within just 3,000 years, without requiring violence or direct competition. The Neanderthal inherited genes in modern humans aren't randomly distributed. We've retained Neanderthal genes related to skin, hair, immune response, and fat metabolism, suggesting these provided adaptive advantages in the Eurasian environments Neanderthals had mastered. Conversely, there's a suspicious absence of Neanderthal DNA on the X chromosome and in genes related to male fertility, potential evidence of reduced fertility in male hybrids, a common pattern in cases of interbreeding between populations with significant genetic distance. Archaeological evidence provides additional clues to the nature of interactions. Despite early theories emphasizing warfare, direct evidence of violent conflict between Neanderthals and modern humans is surprisingly scarce in the archaeological record. There are isolated instances, like a Neanderthal from Shanidar Cave with a wound consistent with a projectile point, but nothing suggesting systematic warfare or genocide. The archaeological signature of their disappearance appears more gradual and complex. More intriguing is evidence of symbolic behavior in late Neanderthal sites. Finds from Cueva de los Avians in Spain include perforated seashells with traces of pigments dated to 115,000 years ago, predating similar modern human artifacts in Europe by 40,000 years. This suggests either independent development of symbolic thinking or, more controversially, that certain modern behaviors might have flowed from Neanderthals to Homo sapiens rather than the reverse, challenging our species-centric view of prehistoric innovation. The picture that emerges is increasingly complex. There was no single cause for Neanderthal extinction, but likely a perfect storm of factors: climate change, demographic challenges, competition for resources, and genetic absorption through interbreeding. But major questions remain unanswered. If Neanderthals were so well adapted to Europe, why did they ultimately fail where modern humans succeeded? If interbreeding was occurring, why didn't this create a hybrid population rather than leading to Neanderthal disappearance? Perhaps most perplexing, what was it about modern humans that allowed us to expand into virtually every environment on Earth while Neanderthals, despite their larger brains and robust physiology, remained limited to a single continental region? Recent discoveries continue to upend established narratives. In 2018, researchers identified the first known first-generation hybrid, a teenage girl from Denisova Cave in Siberia with a Neanderthal mother and Denisovan father, evidence that different human types regularly interbred. In Western Europe, new dating techniques have revealed modern humans arrived earlier than previously thought, around 45,000 years ago rather than 40,000. This extended period of coexistence makes the Neanderthal disappearance even more puzzling. The most provocative recent evidence comes from Neanderthal cave art. Paintings in Spanish caves have been dated to over 65,000 years ago, at least 20,000 years before modern humans arrived in Europe. If accurate, this forces us to reconsider Neanderthal cognitive capabilities. As we follow the evidence, we find ourselves facing a profound mystery that grows deeper rather than simpler with each new discovery. The more we learn about Neanderthals, the more impressive they appear, and the more puzzling their disappearance becomes. Were they victims of climate change, outcompete by our ancestors, genetically absorbed, decimated by disease, or some combination of these factors? The answer remains elusive, hidden in caves and rock shelters across Europe and Western Asia, waiting to be uncovered. What we do know with certainty is this: for over 300,000 years, Earth hosted another kind of human with their own culture, technologies, and ways of understanding the world. Then, within a few thousand years of our arrival, they vanished, leaving only bones, stones, and genetic echoes. The implications of this story extend far beyond academic interest. As we face our own planetary challenges, the disappearance of a highly successful human species serves as both warning and mystery. What makes one human population resilient while another vanishes? As we delve deeper into the evidence, new questions emerge that challenge our understanding not just of Neanderthals, but of ourselves. If another type of human could disappear after hundreds of thousands of years of success, what does that reveal about our own species' future? Chapter 5: The Contradictions in the Fossil Record. As we delve deeper into the Neanderthal mystery, contradictions emerge that challenge our understanding. While the broad narrative suggests a gradual replacement by modern humans, individual sites tell more complex stories that don't always align with this simplistic view. Consider El Sidrón Cave in northern Spain. Here, archaeologists discovered the remains of 13 Neanderthals, 6 adults, 3 adolescents, 2 juveniles, and 2 infants, all showing clear evidence of cannibalism. Their bones had been defleshed, cracked open, and the marrow extracted. Dating places this grisly scene around 49,000 years ago, before modern humans had reached this region of Europe. This wasn't competition between species, but evidence of desperation among Neanderthals themselves, potentially triggered by environmental stress rather than human conflict. Similarly puzzling is the evidence from Mezmyiskaya Cave in Russia's Caucasus Mountains. Neanderthal remains here date to around 39,700 years ago, a time when modern humans had already established communities in the region. Yet no evidence of interaction or conflict appears at the site. Even more striking is what genetic analysis revealed about the Mezmyiskaya Neanderthal infant. Its DNA showed no evidence of modern human admixture, despite living at a time when interbreeding was occurring elsewhere. Different Neanderthal groups had different fates and histories. These site-specific contradictions suggest we're missing important elements of the story. The extinction wasn't uniform across time and space, but played out differently depending on local conditions, the specific Neanderthal populations involved, and their particular relationships with incoming humans. The tools they left behind present another set of contradictions. The Chattelperonian industry, once considered the work of early modern humans in Europe, is now widely attributed to late Neanderthals who adopted or independently invented techniques previously associated only with Homo sapiens. This technological sophistication appears primarily in regions where Neanderthals and modern humans overlapped, suggesting either cultural exchange or that Neanderthals were independently developing more complex tools in response to the same environmental pressures facing modern humans. If Neanderthals could adopt or independently develop these advanced technologies, why did they still disappear? The conventional narrative of cognitive or technological inferiority begins to crumble when we examine these late Neanderthal innovations. Even more contradictory is the evidence of symbolic behavior. Cave art in Spain's La Paisiega, Maltreviso, and Ardales caves has been dated to over 65,000 years ago, at least 20,000 years before modern humans arrived in Europe. If these dates are accurate, Neanderthals were creating symbolic representations long before meeting Homo sapiens. This isn't a simple story of a more advanced species replacing a more primitive one. It's the disappearance of a human type with its own complex cultural evolution. The genomic evidence presents additional contradictions. While interbreeding clearly occurred, the pattern is not what we might expect from gradual absorption. Neanderthal DNA appears in modern humans in distinct chunks, rather than being evenly distributed throughout our genome. This pattern suggests limited interbreeding events rather than consistent mixing over generations. If extensive interbreeding were the primary mechanism of Neanderthal disappearance, we would expect more Neanderthal genetic material and a more even distribution in modern populations. Furthermore, the specific Neanderthal genes we've retained often relate to immune function, skin and hair characteristics, and fat metabolism, adaptive advantages in Eurasian environments. Why would natural selection favor these specific Neanderthal genes while eliminating others? The demographic evidence presents perhaps the most significant contradiction. Recent population estimates suggest Neanderthals always lived in small, scattered groups with a total population perhaps never exceeding 70,000 individuals across their entire range. Modern humans, by contrast, maintained larger, more connected population networks. Even with equal or inferior technology, this demographic advantage alone might have sealed the Neanderthals' fate, not through conflict, but through basic population mathematics and resource competition. If Neanderthals typically lived in groups of 50 to 100 individuals, while early modern human bands averaged 150 to 200, even peaceful competition for the same resources would inevitably favor our ancestors over time, regardless of individual Neanderthal capabilities. Contradictions emerge in the timing as well. In some regions, Neanderthals disappear from the archaeological record thousands of years before modern humans arrive, suggesting factors beyond direct competition were already causing their decline. In Italy's Grotta del Cavallo, archaeologists identified what appeared to be modern human teeth alongside distinctly modern human tools dated to 45,000 years ago, suggesting an earlier arrival of our species than previously thought. Each new discovery shifts our understanding of the timeline. The climate record adds another layer of contradiction. While Neanderthals had successfully weathered previous climate shifts over hundreds of thousands of years, the period of their extinction coincided with unusually rapid fluctuations. Heinrich Event 4. These climate oscillations might have affected Neanderthals differently than modern humans. With smaller populations and potentially less long-distance trade networks, Neanderthals may have had fewer buffers against local resource failures during climate instability. Yet if climate were the primary factor, we would expect to see Neanderthals and modern humans equally affected in the same regions. The selective disappearance of one human type suggests more complex dynamics than environmental pressure alone. The distribution of final Neanderthal sites presents additional puzzles. Their last known locations cluster in southern Iberia, traditionally viewed as a final refuge. But why would Neanderthals persist longest precisely in the regions where modern humans had also established their presence? If direct competition were the primary extinction mechanism, we would expect the opposite pattern, Neanderthals surviving longest in regions most isolated from modern human expansion. The contradictory distribution suggests more complex interaction patterns than simple replacement. Further complicating the picture is evidence that Neanderthals were not a homogeneous population. Genetic studies reveal at least 3 distinct Neanderthal lineages: Western, Eastern, and Siberian, with limited gene flow between them. These populations likely faced different challenges and fates. The Western Neanderthals of Spain, France, and Germany were genetically distinct from those in the Caucasus and Siberia. Some groups may have disappeared through competition with modern humans, others through climate pressures, and still others through absorption via interbreeding. Perhaps most contradictory is the evidence from Denisova Cave in Siberia. Here, researchers not only found Neanderthal remains, but identified a previously unknown human species, the Denisovans, who coexisted and interbred with both Neanderthals and modern humans. The discovery of Deni, a young girl who was the direct offspring of a Neanderthal mother and Denisovan father, demonstrates that different human types regularly interbred. This calls into question the very species categories we use to understand human evolution. If these different human types could produce fertile offspring, were they truly separate species? Should we instead view them as subspecies or populations? These questions aren't merely semantic. They fundamentally change how we understand the Neanderthal disappearance. Rather than extinction in the traditional sense, perhaps what we're seeing is a complex process of absorption, replacement, and genetic dilution, with cultural, technological, environmental, and demographic factors all playing interconnected roles in a process that varied by region. As we examine these contradictions, the simplistic narrative of modern humans simply replacing Neanderthals dissolves. What emerges instead is a complex mosaic of interactions across time and space, different outcomes in different regions, with multiple causal factors at work simultaneously. The Neanderthal disappearance isn't a single mystery, but many interconnected ones. Each archaeological site, each genome analysis, each climate record tells part of the story, and sometimes these parts don't neatly align with one another. Science progresses by addressing contradictions rather than ignoring them. The anomalies in the Neanderthal record don't represent failures of understanding, but opportunities for deeper insight, clues to aspects of the story we've yet to fully comprehend. Chapter 6: Whispers from the Ancient World. Beyond the tangible evidence of bones and stones lie more nebulous clues to the Neanderthal fate, traces preserved in folklore, oral traditions, and puzzling archaeological findings that don't fit neatly into conventional narratives. These elements form the shadowy edges of our understanding. Could memories of encounters with Neanderthals have persisted in human cultural memory? Some anthropologists suggest that widespread myths of wild men living in mountains and forests might preserve distant recollections of our interactions with these other humans. From the European legends of trolls and ogres to Central Asian tales of the Almas, folklore worldwide contains references to powerful, hairy beings that share landscapes with humans, beings that are neither animal nor fully human in the storyteller's conception. These myths typically describe creatures of great physical strength, often dwelling in caves or remote areas, sometimes kidnapping humans or interbreeding with them. While such stories could be pure invention, they might also contain kernels of cultural memory from a time of coexistence. The Basque people of the Pyrenees Mountains between Spain and France have particularly intriguing folklore. Their traditions speak of the Gentilac, powerful beings who lived in the mountains before retreating from the arrival of Christianity. The physical descriptions sometimes echo Neanderthal characteristics. More compelling is the Basque language itself, Euskera. Linguists consider it an isolate, unrelated to any other living language. Could this unique language have roots in a time when Neanderthals and modern humans lived side by side in this region? The Caucasus Mountains, another area with a long Neanderthal presence, similarly host unique linguistic diversity and folklore about wild mountain dwellers. Georgian myths speak of the Akakochi, while Ossetian legends tell of the Nightwalker, both described as powerful, hairy forest dwellers. These parallels between folklore and the archaeological record are suggestive, but far from conclusive. Human imagination has always populated wilderness areas with non-human or semi-human beings. Yet the concentration of such myths in regions with long Neanderthal occupation raises questions. Beyond folklore lies more tangible but equally puzzling evidence. Consider the Lion Man of Hohensteinstadel, a 40,000-year-old carved figure combining human and lion characteristics. This oldest known zoomorphic sculpture coincides with the period when both human types coexisted in Europe. Does this half-human, half-animal figure represent something deeper than artistic imagination? Some researchers suggest it might reflect consciousness of different types of humans, a symbolic representation of the hybrid nature of beings produced through Neanderthal modern human interbreeding. Equally puzzling are the handprints found in caves across Europe. At Maltreviso Cave in Spain, handprints dated to over 65,000 years ago show the distinctive shorter fingers associated with Neanderthal anatomy, evidence of symbolic behavior predating modern human arrival. At other sites like Gargas Cave in France, archaeologists have documented dozens of handprints with missing finger joints. While some attribute this to disease or frostbite, others suggest these might represent a communication system, perhaps even evidence of interaction between different human types. Among the most provocative, out-of-place discoveries are those suggesting Neanderthals possessed capabilities traditionally associated only with modern humans. The discovery of a bird bone flute at Divjbabe in Slovenia, potentially made by Neanderthals, hints at musical tradition. Though controversial, some argue the holes in the bone were created by animal teeth rather than human design. This potential Neanderthal flute would rewrite our understanding of their cognitive abilities. Music requires abstract thinking and represents a form of symbolic communication. Similarly challenging is evidence of Neanderthal seafaring. At several sites in the Mediterranean, including Greek islands and Crete, stone tools consistent with Neanderthal design have been found, despite these islands being inaccessible except by boat during the relevant time periods. If Neanderthals were indeed crossing open water to reach these islands over 100,000 years ago, we must radically revise our understanding of their technological capabilities. Such journeys would require planning, boat construction, and navigation skills previously attributed only to modern humans. Perhaps most perplexing is the evidence from Gibraltar's Gorham's Cave, where archaeologists discovered what appears to be a deliberate geometric engraving, a crosshatch pattern carved into the cave floor by Neanderthals around 39,000 years ago. This abstract design, requiring planning and precision to execute, suggests symbolic thought processes. It's neither a tool nor a recognizable representation of anything in the physical world, but rather an abstract pattern created for purposes we can only speculate about. The cumulative effect of these findings forces us to question fundamental assumptions about Neanderthal capabilities. If they created art, music, and abstract symbols, if they navigated open water and engaged in complex symbolic behaviors, why did they still disappear? One intriguing possibility emerges from studies of modern human uniqueness. While Neanderthals may have possessed many or most of our cognitive abilities, subtle differences in social structure might have proved decisive during times of environmental stress. Archaeological evidence suggests Neanderthal social groups were smaller and less interconnected than those of modern humans. Our ancestors appear to have maintained larger trading networks, exchanged materials over longer distances, and potentially had more complex social hierarchies. These differences in social organization, rather than individual cognitive abilities, might explain the divergent fates of the two human types. In times of scarcity, larger, more connected social networks provide crucial advantages through resource sharing and information exchange. Another provocative hypothesis concerns differences in language capabilities. While Neanderthals possessed the anatomical structures for speech, subtle differences in brain organization might have resulted in different linguistic capacities, affecting their ability to coordinate large-scale activities. The FOXP2 gene, associated with language development, shows slight differences between Neanderthals and modern humans. Could these minor genetic variations have resulted in qualitatively different communicative abilities, subtle enough to leave no clear archaeological signature, but significant enough to affect survival? Challenging the boundary between evidence and speculation are findings suggesting ritual behaviors among Neanderthals. At La Chapelle-aux-Saints in France, a Neanderthal skeleton appears to have been deliberately placed in a prepared pit, possibly with grave goods. At Breniquel Cave in France, archaeologists discovered structures made from broken stalagmites arranged in circles, dated to 176,500 years ago, deep inside a cave where no daylight penetrates. Only Neanderthals existed in the region at this time. The purpose of these structures remains unknown, but their deliberate arrangement deep inside a dark cave suggests activity beyond mere survival needs, possibly ritual or ceremonial purposes that hint at a spiritual dimension to Neanderthal life. These puzzling findings force us to question whether we're asking the right questions about Neanderthal disappearance. Perhaps what needs explanation isn't why a primitive human type vanished, but why two equally complex forms of humanity had such different fates. The traditional boundary between myth and science begins to blur when we consider the most recent potential evidence of Neanderthal survival. Sporadic reports from remote mountainous regions of Central Asia describe encounters with hairy, powerful beings walking on two legs. While mainstream science dismisses these as misidentifications or folklore, some researchers suggest the possibility, however remote, that isolated Neanderthal populations might have persisted in remote regions far longer than the archaeological record currently indicates. Similar claims have emerged from the Caucasus Mountains and remote areas of Siberia. Indigenous peoples in these regions maintain traditions of wild people that some speculative researchers link to potential late-surviving Neanderthal populations. The scientific consensus firmly places the last Neanderthals around 40,000 years ago, with controversial evidence suggesting possible survival until 28,000 years ago in Gibraltar. Claims of more recent survival remain firmly in the realm of cryptozoology rather than mainstream archaeology. Yet the boundaries between established science and frontier speculation have shifted before. When the first Neanderthal specimen was discovered in 1856, many scientists considered it simply a deformed modern human. The concept of an extinct human species seemed too fantastic. As we continue to uncover evidence that forces us to revise our understanding of Neanderthal capabilities, we must remain open to the possibility that future discoveries might similarly transform our conception of their disappearance, and perhaps even how complete that disappearance was. Chapter 7: The Last Human Extinction. As we assemble the fragments of the Neanderthal story, a profound realization emerges. We're not merely investigating an ancient mystery. We're examining the most recent extinction of a human species. This wasn't the disappearance of some distant evolutionary cousin, but our closest relatives. The implications extend far beyond academic interest. If a human species that survived for over 300,000 years could disappear after our arrival, what does this reveal about the nature of extinction itself? And more unsettlingly, what might it suggest about our own species' vulnerability? Consider the time frame. Neanderthals vanished approximately 40,000 years ago. Our own species has existed for roughly 300,000 years, about the same duration as the Neanderthal timeline. Their entire existence and disappearance is not prehistory, but a preview of possible human futures. This perspective transforms how we understand the stakes of the mystery. The Neanderthal extinction represents a case study in human vulnerability, a sobering reminder that evolutionary success over hundreds of millennia provides no guarantee of indefinite survival. What makes this particularly relevant is that many factors implicated in their disappearance resonate with contemporary challenges. Climate instability, population pressure, resource competition, and potential pandemic disease. These are not merely ancient threats, but modern ones. If Neanderthals, despite their larger brains and robust physiology, could not withstand these pressures, what assurance do we have that our own adaptations, primarily cultural and technological rather than biological, will prove more effective over similar timeframes? The genetic evidence adds another dimension to these stakes. Those of us with Eurasian ancestry carry Neanderthal DNA within us, not as a distant memory, but as functional elements of our biology. Their extinction was not complete because parts of them survive in us. Some Neanderthal-derived genes influence our immune response to pathogens, our skin's adaptation to ultraviolet radiation, and our metabolism of fats. These genetic contributions represent a living legacy, adaptations developed over hundreds of thousands of years that benefited our ancestors. Had Neanderthals disappeared completely without genetic admixture, modern humans might have faced greater challenges adapting to Eurasian environments. Their extinction with genetic contribution represents both a loss and a partial preservation of adaptations honed over millennia. This reframes the stakes of understanding their disappearance. We're not simply solving a historical puzzle, but potentially extracting lessons about human resilience and vulnerability, insights that might prove crucial as we face our own extinction-level challenges. Consider the environmental parallels. Neanderthals faced rapid climate oscillations during Heinrich Event 4, sudden warming and cooling cycles that stressed ecosystems beyond their adaptive capacity. Today, we face human-induced climate change occurring at rates unprecedented in human history. If climate fluctuations contributed to Neanderthal extinction despite their long adaptation to Ice Age conditions, how confident should we be in our own resilience to environmental changes occurring at speeds tens or hundreds of times faster? The demographic dimension adds another parallel. Neanderthals existed in small, scattered populations, potentially making them vulnerable to localized disasters, genetic bottlenecks, and resource fluctuations. Modern humans, while far more numerous, face different demographic challenges. Our massive population depends on complex global systems for food, energy, and resources. These interconnected networks provide resilience through redundancy, but also create systemic vulnerabilities, cascading failures that could affect billions simultaneously rather than small, isolated bands. The technological comparison is equally revealing. Neanderthals mastered fire, crafted sophisticated stone tools, and potentially developed early forms of composite technology. Yet these innovations proved insufficient against the combined pressures they faced. Our own technology is incomparably more advanced, yet creates new vulnerabilities alongside new capabilities. Nuclear weapons, engineered pathogens, artificial intelligence. Our tools have outpaced our wisdom, creating extinction risks that no previous human species ever faced. Perhaps most sobering is the social dimension. Evidence suggests Neanderthals lived in smaller groups with less extensive trade networks than early modern humans. This social limitation may have proved decisive during crisis periods when resource sharing became essential for survival. Today, despite our global connectivity, we struggle to coordinate effective responses to planetary challenges. If social cohesion and cooperation were factors in Neanderthal extinction, our own social fragmentation, despite technological connectivity, represents a profound vulnerability. The disease hypothesis for Neanderthal extinction resonates particularly in our post-pandemic world. If pathogens carried by modern humans contributed to their disappearance, we're witnessing a modern version of the same vulnerability as emerging diseases spread through global travel networks. The key difference is scale and speed. A pathogen that might have taken generations to spread through scattered Neanderthal populations can now circumnavigate the globe in days. Our connectedness creates both resilience through shared medical knowledge and vulnerability through transmission vectors. Looking at these parallels, the stakes of the Neanderthal mystery escalate from historical curiosity to existential insight. Their extinction may contain warnings about the precariousness of human existence, lessons written in the archaeological record that we ignore at our peril. Most profound is what their disappearance reveals about evolutionary timescales versus extinction events. Neanderthals evolved over hundreds of thousands of years, adapting precisely to their environmental niche. Yet their extinction occurred within a few thousand years, an evolutionary eye blink. This asymmetry between adaptation and extinction characterizes many species' fates. Evolutionary processes work gradually across countless generations, while extinction can occur within a single generation when conditions change too rapidly for adaptation to keep pace. For most of human existence, this pattern seemed to exclude us. Unlike other species, we adapt primarily through culture and technology rather than biological evolution, allowing us to respond to environmental changes within a single generation rather than over evolutionary time. But the Neanderthal case suggests caution. They too possessed cultural adaptation through tool-making traditions, knowledge transmission, and possibly language. These capabilities sustained them for hundreds of millennia, but ultimately proved insufficient against combined pressures. Their disappearance forces us to consider whether our own cultural adaptability has limits, thresholds beyond which even human ingenuity cannot respond quickly enough to multiplying threats. The stakes of understanding their extinction include insights into these potential limitations. The Neanderthal mystery also illuminates questions of human uniqueness. If they possessed art, symbolic thinking, tool technology, and potentially language, what made our species different enough to survive while they vanished? The answer may reveal essential aspects of human resilience. Some research suggests modern humans maintained larger, more connected social networks, potentially enabling more effective resource sharing during crises. Others point to subtle cognitive differences that might have facilitated more adaptive responses to rapid environmental changes. Whatever the key differences, identifying them could prove crucial for our future. If certain social structures, cognitive tendencies, or cultural practices provided decisive survival advantages during past human extinction events, cultivating these qualities might be essential for facing future challenges. The ultimate stakes of the Neanderthal disappearance lie in what it reveals about extinction itself. It wasn't inevitable. Slight changes in climate patterns, pathogen evolution, or interaction dynamics might have led to coexistence rather than replacement. This contingency, the sense that things could have gone differently, underscores the precariousness of human existence. Our own species' dominance appears in retrospect like destiny, but the Neanderthal case reveals it as one possible outcome among many, shaped by factors not fully under our control. Their disappearance represents what scientists call a natural experiment, a case where we can observe how certain factors influence outcomes without deliberately creating experimental conditions. The results of this experiment contain lessons we urgently need to understand. As we face accelerating climate change, biodiversity collapse, emerging diseases, and technological risks unprecedented in human history, the story of the last human extinction takes on immediate relevance. We are not merely solving an ancient mystery, but potentially preventing a future one. The Neanderthal disappearance represents more than the loss of a human species. It embodies the loss of a unique way of being human, a distinct consciousness, perhaps even a different mode of perceiving and experiencing the world that evolved over hundreds of thousands of years. This dimension of the loss transcends scientific measurement. We cannot quantify the extinction of a way of seeing, thinking, and being. Yet this may be the most profound aspect of their disappearance, the forever loss of a human perspective that developed along a separate evolutionary path. Had Neanderthals survived alongside us into the present, our concept of humanity itself would be fundamentally different. Philosophy, religion, ethics, and science would all need to accommodate multiple forms of human consciousness coexisting on Earth, a plurality we can now only imagine. Instead, we inhabit a strangely solitary world where only one human species exists, an evolutionary singleton unlike anything seen for millions of years of hominin history. This solitude shapes our thinking about ourselves in ways we rarely examine. The revelation that parts of Neanderthals live on in our genes offers a poignant counterpoint to their extinction. They are simultaneously gone and present, vanished as a distinct people, yet persisting within many of us as genetic echoes of ancient encounters. This biological legacy transforms how we conceptualize human identity. Those of us with Neanderthal ancestry are, in a very real sense, hybrids, the living embodiment of an ancient convergence between two human lineages that had developed separately for hundreds of thousands of years. As we approach the final chapters of our investigation, the stakes have transcended historical curiosity. Understanding the Neanderthal disappearance isn't merely about resolving an ancient mystery. It's about comprehending the fundamental nature of human vulnerability and resilience. What we discover may help us navigate our own existential challenges, not because history repeats exactly, but because the patterns of human adaptation, crisis, and response contain insights that transcend specific times and populations. The Neanderthals were not simply an evolutionary dead end, but our evolutionary siblings, a parallel humanity that walked a different path. Their story isn't separate from ours, but interwoven with it. And their extinction may contain warnings we cannot afford to ignore. Chapter 8. The Final Days, Competing Theories. As we approach the climax of our investigation, we must confront the leading theories that attempt to explain the Neanderthal disappearance. Each hypothesis has its advocates within the scientific community, and each is supported by compelling evidence. Yet none alone seems sufficient to explain this ancient mystery. The first major theory centers on direct competition with modern humans. This traditional explanation suggests that Homo sapiens, upon entering Europe around 45,000 years ago, simply outcompete Neanderthals for the same resources, a classic case of ecological replacement. Evidence supporting this theory includes the clear chronological correlation between modern human arrival and Neanderthal decline across different regions. The pattern is consistent. Wherever modern humans appear in the archaeological record, Neanderthals begin to disappear shortly thereafter. Modern humans possessed several potential competitive advantages. Their more slender physique required fewer calories to maintain, allowing survival on fewer resources during periods of scarcity. Their technology included projectile weapons that permitted hunting at safer distances. Archaeological evidence shows modern humans maintained larger social networks, indicated by exotic materials transported over much greater distances than observed in Neanderthal sites. These extended networks could have provided crucial advantages during resource shortages. Language differences may have played a role as well. While Neanderthals likely possessed some form of language, subtle distinctions in communication capabilities could have enabled more effective coordination among modern humans during hunting or conflict. But this competition theory has significant weaknesses. If direct resource competition were the primary factor, we would expect to see evidence of increased hunting pressure on the same animal species after modern human arrival. Yet this pattern isn't consistently observed. Furthermore, if modern humans were simply more effective competitors, why did Neanderthals persist alongside them in some regions for thousands of years? The extended period of coexistence in parts of Europe suggests the relationship was more complex than straightforward replacement. The second major theory focuses on climate change as the primary driver of Neanderthal extinction. The period between 43,000 and 38,000 years ago coincided with Heinrich Event 4, a period of extreme climate instability characterized by rapid shifts between warming and cooling. Neanderthals had evolved specifically for cold conditions, with body proportions optimized for heat conservation. Paradoxically, some research suggests they may have been more vulnerable to the rapid warming events that punctuated this period than to the cold phases. Their specialized anatomy and cultural adaptations to cold environments may have become disadvantages during rapid warming periods, creating physiological stress that modern humans, evolved in Africa with more heat-adapted bodies, did not experience as severely. Furthermore, climate instability would have affected plant and animal distributions, potentially disrupting the resource base Neanderthals had relied upon for hundreds of thousands of years. This environmental volatility might have pushed already small populations below sustainable thresholds. Evidence supporting this climate hypothesis includes the correlation between Neanderthal disappearance and Heinrich Event 4. Additionally, studies of pollen samples from this period indicate significant vegetation changes that would have affected the animals Neanderthals hunted. The climate theory aligns with the regional pattern of extinction, with Neanderthals persisting longest in southern refugia like Gibraltar, areas where climate fluctuations would have been somewhat buffered compared to more northern regions. However, this theory too has weaknesses. Neanderthals had previously survived multiple climate shifts over their long evolutionary history, including earlier Heinrich events and other rapid fluctuations. Why would this particular climate episode prove fatal when previous ones did not? Additionally, if climate were the sole factor, we would expect both human species to be similarly affected in the same regions. The selective disappearance of Neanderthals suggests other factors must have been involved beyond environmental pressures alone. The third major theory proposes demographic factors as the key to understanding Neanderthal extinction. According to this hypothesis, Neanderthals always existed in small, scattered populations with limited genetic diversity, making them inherently vulnerable to extinction. Genetic studies of Neanderthal remains reveal concerning levels of inbreeding and low genetic diversity compared to contemporary modern human populations. This limited genetic pool would have made them more vulnerable to disease, reduced fertility, and other consequences of inbreeding depression. Mathematical models suggest that even modest differences in fertility rates or mortality between the two human populations could have led to Neanderthal extinction within a few thousand years. without requiring direct conflict or competition. The genetic evidence partially supports this demographic hypothesis. Analysis of Neanderthal genomes indicates they likely never numbered more than a few thousand breeding individuals at any given time, compared to much larger modern human populations. Furthermore, genetic studies suggest Neanderthal populations experienced several severe bottlenecks throughout their history, periods when their numbers declined dramatically before recovering. These repeated bottlenecks would have reduced their genetic diversity and resilience. This theory aligns with the pattern of gradual disappearance observed in the archaeological record. Rather than a sudden extinction event, Neanderthals seem to have slowly dwindled across different regions, consistent with demographic absorption rather than rapid replacement. But this theory also has limitations. If low population density alone determined extinction risk, Neanderthals should have disappeared long before modern human arrival, during previous climate crises. Their long persistence suggests effective adaptations that compensated for small population sizes. Additionally, the demographic hypothesis doesn't fully explain why Neanderthals disappeared completely rather than reaching a stable, if reduced, population in certain regions, particularly in areas where they had thrived for hundreds of thousands of years. A fourth hypothesis combines elements of these theories with the idea of assimilation through interbreeding. This model suggests Neanderthals didn't truly go extinct, but were gradually absorbed into the larger modern human population through genetic mixing over generations. The genetic evidence strongly supports some level of interbreeding. All non-African humans today carry Neanderthal DNA, conclusively demonstrating that the two populations produced fertile offspring. These hybridization events permanently incorporated Neanderthal genes into our species. Mathematical modeling suggests that even relatively low levels of interbreeding, as little as 5% per generation, could lead to apparent extinction through genetic absorption within a few thousand years, without requiring violence, competition, or catastrophic environmental change. This assimilation theory aligns with the gradual nature of Neanderthal disappearance and explains why certain Neanderthal genes persist in modern populations while others have been selected against. It presents extinction not as an event, but as a gradual process of genomic incorporation. However, if assimilation were the primary mechanism, we might expect to see greater proportions of Neanderthal DNA in modern humans. The relatively small percentage, between 1 to 4% in non-Africans, suggests limited interbreeding rather than wholesale absorption. Additionally, the pattern of Neanderthal genetic contribution is uneven across the genome, with certain regions showing almost no Neanderthal DNA. This suggests selection against some Neanderthal genes, implying potential genetic incompatibilities between the two populations. None of these theories alone fully explains the Neanderthal disappearance. The archaeological and genetic evidence suggests a complex interplay of factors: competition, climate change, demographic vulnerability, and assimilation, working in concert rather than in isolation. The most compelling current model proposes a perfect storm scenario, where a species already vulnerable due to small population size faced simultaneous pressures from climate instability, resource competition with incoming modern humans, and partial genetic absorption through interbreeding. Under this integrated model, different mechanisms would have predominated in different regions and time periods, explaining the varying patterns observed across the archaeological record. No single factor caused their extinction, but together, these pressures proved insurmountable. Chapter 9. The Paradoxes of New Science. Recent scientific advances have transformed our understanding of Neanderthals while simultaneously deepening the mystery of their disappearance. New techniques in ancient DNA analysis, sophisticated climate modeling, and improved archaeological dating methods have revealed paradoxes that challenge previous certainties. Perhaps the most significant recent development is the ancient DNA revolution. When scientists first sequenced the Neanderthal genome in 2010, it transformed our understanding overnight. Subsequent refinements have revealed astonishing details about Neanderthal biology, demographics, and interactions with modern humans. The genetic evidence creates its first paradox. Neanderthals were simultaneously separate from and part of us. Their genetic distinctiveness confirms they followed a separate evolutionary path for hundreds of thousands of years, yet interbreeding shows they weren't a truly separate species. This genomic analysis revealed another paradox. Certain Neanderthal genes provided fitness advantages and were positively selected for in modern human populations, while others were strongly selected against. We incorporated beneficial Neanderthal adaptations while eliminating others. For example, Neanderthal genes related to keratin production, affecting skin, hair, and nails, show signs of positive selection in modern Europeans. These adaptations likely helped our ancestors cope with the colder, less sunny environments of northern latitudes. Conversely, Neanderthal genes on the X chromosome are notably absent in modern humans, suggesting hybrid males may have had reduced fertility, a common pattern when divergent populations interbreed. This genetic incompatibility hints at the limits of assimilation through interbreeding. New genetic studies have revealed another paradox. Neanderthal populations remained extraordinarily small throughout their existence, yet survived for hundreds of thousands of years despite this vulnerability. How did they persist so long with such demographic fragility? The answer may lie in recent discoveries about their social structures. Evidence from El Sidrón Cave in Spain reveals a Neanderthal group consisting of closely related individuals, three brothers, a father-daughter pair, and other relatives living as a tight-knit family unit. This family-based social organization may have provided resilience despite small population sizes, creating stable social structures with strong selective pressure for cooperative behaviors. Yet this same social structure might have limited their ability to expand and connect with other groups. Advanced dating techniques have created another paradox. The traditional narrative suggested modern humans arrived in Europe around 40,000 years ago, rapidly replacing Neanderthals. New dates indicate modern humans reached parts of Europe by 45,000 years ago or earlier. This extended timeline of coexistence, 5,000 years or more in some regions, contradicts the notion of rapid replacement. If modern humans held decisive advantages, why did complete replacement take millennia? And if they didn't, what eventually tipped the scales? Climate science has contributed its own paradoxes. Advanced climate models now reveal that the period of Neanderthal extinction featured extreme weather variability rather than simply colder conditions. Stable cold might have favored Neanderthals, while unpredictability benefited the more adaptable newcomers. This climate instability would have created boom and bust cycles in plant and animal resources. Larger, more connected modern human networks could distribute resources during local shortages, while isolated Neanderthal groups may have faced starvation when local resources failed. Paleoanthropologist John Shea's research creates another paradox. His analysis suggests Neanderthals were not technologically inferior to early modern humans in Europe. Both created similar tools from the same materials with comparable efficiency until around 30,000 years ago. If Neanderthals were not technologically outmatched during most of the replacement period, what eventually gave modern humans their decisive advantage? The answer may lie not in individual capabilities, but in collective behaviors and social structures. Archaeological discoveries at Shagarskaya Cave in Siberia reveal another paradox. Neanderthals their crafted tools identical to those made by their relatives 3,000 miles away in Eastern Europe, suggesting precise knowledge transmission across generations despite minimal population movement. This cultural conservatism, maintaining nearly identical technologies across vast distances and time periods, indicates remarkable stability and successful adaptation. Yet this same characteristic may have limited their capacity to develop novel solutions when faced with unprecedented challenges. Recent cave art dating has produced perhaps the most profound paradox. If the dates of 65,000 plus years for cave paintings in Spain are correct, Neanderthals were creating symbolic art at least 20,000 years before modern humans arrived in Europe. This fundamentally challenges the narrative of cognitive superiority in modern humans. If Neanderthals independently developed abstract symbolic expression, the cognitive gap between our species narrows dramatically, making their disappearance even more puzzling. New research on brain development adds another dimension to this paradox. Paleoneurological studies suggest Neanderthals and modern humans had different patterns of brain growth during childhood, potentially leading to different, but not necessarily unequal cognitive abilities. Modern human brains experience a longer period of plasticity during development, potentially enabling greater cultural flexibility. Neanderthal brains may have developed more rapidly, potentially providing earlier mastery of essential skills, but less lifetime adaptability to novel challenges. Analysis of Neanderthal ear structures suggests they could perceive the same sound frequencies as modern humans, contradicting earlier hypotheses that limited language capacities may have disadvantaged them. Their potential for complex communication appears comparable to our own. Studies of Neanderthal hyoid bones, crucial for speech production, similarly indicate they possess the anatomical structures necessary for language. Combined with genetic evidence showing they carried the same FOXP2 language gene variants as modern humans, the case for Neanderthal language strengthens. Yet another paradox emerges from studies of Neanderthal hunting techniques. They appear to have been highly effective close-range hunters who dispatched dangerous prey through direct confrontation, a high-risk, high-reward strategy that required tremendous skill and strength. Modern humans, by contrast, increasingly relied on projectile weapons that allowed killing from safer distances. This technological difference wouldn't necessarily have provided immediate advantages, but might have reduced modern human mortality rates over generations, a subtle but decisive demographic edge. The most recent genetic studies create a final paradox. Different Neanderthal populations had different fates. Eastern Neanderthals contributed more DNA to present-day populations than Western Neanderthals, despite Western groups having longer periods of contact with modern humans. This regional variation suggests the extinction story played out differently across their range. Not one process, but many, with different mechanisms predominating in different regions. The complexity of this pattern defies simple explanations. Each new scientific advance seems to simultaneously clarify specific aspects of the Neanderthal story while making the overall pattern of their disappearance more enigmatic. They were like us, but not us, similar enough to interbreed, yet different enough to vanish. Chapter 10: The Mosaic Extinction. We've reached the culmination of our investigation into one of prehistory's greatest mysteries. After examining competing theories and the latest scientific evidence, we can now attempt to reconstruct what actually happened to the Neanderthals, a story more complex than previously imagined. The traditional narrative of inferior beings replaced by more advanced newcomers has crumbled under the weight of evidence. Neanderthals were not cognitively or technologically outmatched in any straightforward sense. Their disappearance requires a more nuanced explanation. What emerges instead is what scientists now call a mosaic extinction, different factors predominating in different regions and time periods, creating a pattern where no single cause led to their disappearance, but rather a complex interplay of pressures that varied across time and space. In some regions, particularly Eastern Europe and Central Asia, the primary mechanism appears to have been assimilation through interbreeding. Genetic evidence shows higher contribution of Neanderthal DNA from these populations, suggesting more extensive genetic mixing with modern humans. The initial encounters between these human types likely occurred in the Middle East around 100,000 years ago. Early interbreeding events are preserved in our DNA, showing that interaction and gene flow began long before the final disappearance of distinct Neanderthal populations. The viability of these hybrid offspring, carrying both Neanderthal and modern human genes, challenges the very concept of separate species. In biological terms, Neanderthals and modern humans might better be understood as subspecies or populations rather than distinct species. This interbreeding created new possibilities and challenges. Beneficial Neanderthal adaptations to Eurasian environments could be incorporated into modern human populations, while genetic incompatibilities might have reduced fertility in some hybrid individuals, particularly males. In Western Europe, a different pattern emerges. Here, the archaeological record suggests more direct competition between the two human types, with modern humans gradually expanding into territories previously occupied exclusively by Neanderthals. This competition wasn't necessarily violent conflict, though isolated instances may have occurred, but rather a more subtle process of resource competition. Modern humans' more extensive social networks may have provided crucial advantages during periods of resource scarcity. Recent climate modeling reveals that Western Europe experienced particularly dramatic climate fluctuations during this period. These environmental stresses would have affected both human types, but modern humans' larger population size and wider trade networks provided greater resilience. In Iberia, modern Spain, and Portugal, Neanderthals persisted the longest, surviving until around 40,000 years ago. This southern refuge provided more stable climate conditions, allowing the final Neanderthal populations to endure while their northern relatives had already disappeared. What we're seeing is not a single extinction event, but a drawn-out process spanning thousands of years, playing out differently across the Neanderthal range, shaped by local conditions, population densities, climate patterns, and the nature of interactions with modern humans. The demographic factor proves particularly significant in this mosaic. Genetic evidence confirms Neanderthals maintained remarkably small population sizes throughout their existence, perhaps never exceeding 70,000 individuals across their entire range, and typically much fewer. This demographic fragility meant even small shifts in birth rates, death rates, or sex ratios could have dramatic effects over generations. Mathematical modeling shows that a mere 2% difference in population growth rates would lead to effective extinction within a few thousand years. Modern human groups, with their larger and more connected populations, possessed a powerful demographic advantage. Even with identical individual capabilities, this population difference alone might have determined the eventual outcome of the interaction between the two human types. The climate factor cannot be separated from these demographic dynamics. The extreme weather variability of Heinrich Event 4 would have created boom and bust cycles in local resources. Groups that could distribute resources across larger networks had inherent advantages during local shortages. Neanderthal populations, typically living in groups of 50 to 100 individuals with limited contact between bands, would have been more vulnerable to local resource failures than modern humans, who maintain trading relationships across much greater distances. The technological factor plays a more subtle role than previously thought. While Neanderthals were not technologically inferior in terms of manufacturing capability, modern humans increasingly adopted projectile weapons that reduced injury and death rates during hunting. This technological difference wouldn't have provided immediate dominance, but could have created slight differences in mortality rates that, combined with other factors, contributed to gradual demographic advantage for modern humans over generations. The cultural dimension adds another layer. Evidence suggests modern humans maintained more fluid social structures, forming larger temporary gatherings for collective activities before dispersing again. This social flexibility may have enabled more rapid cultural adaptation to changing conditions. Neanderthals, by contrast, appear to have maintained more stable, family-based groups with remarkable cultural consistency over time. This social structure provided resilience during stable periods, but may have limited their adaptability during times of unprecedented change. What ultimately emerges is not a story of replacement, but one of merger and continuation. Neanderthals didn't simply disappear. Parts of them survive in most non-African humans alive today. Their extinction was partial rather than complete. The Neanderthal lineage continues within our own species, not as a distinct population, but as an integrated genetic component of modern humanity. Between 1 to 4% of the genome of non-African people comes directly from Neanderthal ancestors. This genetic legacy isn't randomly distributed, but concentrated in genes related to immune function, skin and hair characteristics, fat metabolism, and other traits that would have been adaptive in Eurasian environments. Natural selection preserved beneficial Neanderthal genes while eliminating others. The mosaic pattern of their disappearance reflects the complexity of human history itself. Different mechanisms predominated in different regions: assimilation in some areas, competition in others, demographic absorption elsewhere, creating a pattern too complex for any single cause explanation. What happened to the Neanderthals, ultimately, was not that they were replaced by a superior species. Rather, they encountered another human population at a vulnerable moment in their evolutionary history, when climate instability was already stressing their small, scattered communities. This encounter set in motion a complex process of interaction, including competition, cultural exchange, and interbreeding, that played out differently across their range. In some regions, they were primarily absorbed genetically. In others, they dwindled through demographic disadvantage. The final revelation is that there was no final revelation, no single dramatic event that ended their existence. The Neanderthal disappearance was a drawn-out process spanning thousands of years, a gradual diminishing rather than a dramatic extinction. Their story ends not with a bang, but with a whisper, a gradual fading as their distinctive features were diluted through interbreeding. Their territories contracted through competition, and their populations dwindled through demographic disadvantage and environmental stress. Yet in another sense, their story doesn't end at all. The Neanderthal contribution continues within us, in our genomes, in our adaptations to northern environments, and in our understanding of what it means to be human. They are gone, yet part of them remains. The mystery of the Neanderthal disappearance ultimately reveals not a simple answer, but a profound truth about human existence itself. That our story is not a linear march of progress, but a complex braiding of lineages, a mosaic of adaptations, extinctions, and transformations that continues to unfold. As our investigation concludes, we're left with a paradox. The Neanderthals are simultaneously gone and present, vanished as a distinct population, yet continuing within the genetic makeup of billions of people alive today. Their disappearance was both an ending and a transformation. This resolution changes how we understand human identity itself. Those of us with Eurasian ancestry are not purely Homo sapiens, but hybrids carrying the genetic legacy of different human lineages. The boundaries between human types were more permeable than we once believed. The Neanderthal story forces us to confront our own precariousness. A human species that thrived for hundreds of thousands of years disappeared within a few millennia of encountering our ancestors. Their fate reminds us that evolutionary success provides no guarantee of permanence. As we face our own global challenges, climate change, biodiversity collapse, emerging diseases, the Neanderthal disappearance takes on new significance. What combination of factors might threaten our own species' future? What lessons can we draw from their gradual decline? Perhaps most profound is what their existence and disappearance reveal about human uniqueness. For most of human history, multiple types of humans shared the planet. Our current solitude as the only human species is the exception, not the rule, an evolutionary anomaly. Had circumstances been slightly different, a change in climate patterns, variation in population dynamics, or altered patterns of interaction, we might today share Earth with other human species. Our solo status is not the inevitable outcome of evolution, but a historical contingency. The Neanderthals were not failed humans or evolutionary dead ends. They were a viable, successful variant of humanity that existed 20 times longer than recorded civilization. Their disappearance represents not their failure, but a profound loss of human diversity. In their bones and genes, in the tools they crafted and the caves they painted, the Neanderthals left us a message about human possibility, a reminder that being human has never been a single, fixed condition, but a spectrum of adaptations and potentials. As we contemplate their silent caves and empty hearths, we're confronted with both loss and continuity. Their lineage persists within us, their adaptations live on in our biology, and their story intertwines with our own. They are the others who became part of us. If you've enjoyed this exploration of one of prehistory's greatest mysteries, consider subscribing for more journeys into the shadows between what we know and what we can only imagine, the borderlands where science encounters mystery and where the past may hold lessons for our future.